The dimensions of a rectangular box are 168 by 132 by 84 cm. The box is to be filled with identical cubes so that there will be no empty space. Part 1. Find the longest possible length of each side of the cube. Hence, find the number of cubes that the box can contain. So let me just draw it out just to see what exactly is happening in this question. Okay, so we have a box like this. Okay, so over here is 168 cm. Over here is 132 cm. And over here is 84 cm. Okay, so you're trying to fit in some cubes so that there will be no empty space. Find the longest possible length. So what is the common length that I can fit in across the length, across the breadth, and across the height? Common length. The longest possible common length across the length, breadth, and height. Alright, why does it have to be a common length? Because in a cube, in these red cubes that you're trying to fit in, the dimensions of the cubes are all the same, they are all common. Okay, so basically when you see this word longest possible length and you want to try and fit in some common length, you are trying to find the HCF of these three numbers. Okay, so what we need to do is find the prime index notation of 168, 132, and 84 as well. So let's do that very quickly. So for 168, we can put it into divided by 2 here, you get 84. Further divide by 2, you get 42. Further divide by 2, you get 21. Divided by 3, you get 7. Divided by 7, you get 1. Okay, so 168 is nothing but 2 cubed times 3 times 7. Alright, so we do the same thing for 132. Okay, so you divide by 2 first, you get a 66. Further divide by 2, you get 33. Divide by 3, you get 11. Divide by 11, you get 1. So 132 will be equals to 2 squared times 3 times 11. Okay, so we do the same thing for 84 now. Divide by 2 first, you will get a 42. Divide by 2 next, you get 21. Divide by 3, you get 7. Divide by 7, you get 1. Alright, so 84 is just 2 square times 3 times 7. So we can find the HCF of these three numbers. To find the HCF, we take the lowest possible powers. So 2 square is the lowest. 3, all are as low, so we'll just put a 3 here. 7, no 7, 7. So if the lowest possible is no 7, do not take any 7. 11, no 11, no 11. The lowest possible is no 11, so don't take the 11. 2 square times 3 is our HCF, which is 4 times 3, which is going to be 12 centimeter. This is the longest possible length of your cube. Part 1 is done. Hence, find the number of cubes that the box can contain. Part 2. Across the length, how many of these cubes can you fit? How many of the 12 cm can you have? 168 divided by 12. (14 cubes across the length. This is across the length. Across the breadth, how many cubes can you fit in? 132 divided by 12 as well. (11 across the breadth and across the height. 84 divided by 12 as well. You get 7 across the height. So in total, how many cubes can you fit? 14 times 11 times 7. You have 14 here, you have 11 here, and you have 7 here. Final answer, 1078 cubes. Now another method to do this, right, for part 2, you can find the total volume of this box first. 168 length times breadth times height, and then you take this total volume, divide by the volume of each cube, which is 12 times 12 times 12. Okay, so let's see. 168 times 132 times 84. Oh, it's quite a big number. Divide by 12 times 12 times 12. At the end, right, you will still get 1078. Exactly the same answer.